Hello, as you can see in this question, it is asked and an object is dropped from a great height and falls through the air of uniform density. The acceleration of free fall is g, which graph could show the variation with time t of the acceleration a of the object. So along y, it is acceleration, along t, it's time. Okay, now which of the graph will show us the perfect g variation or acceleration variation? Now we know that when a ball is falling because of the surface, it will experience resistive force upwards due to the presence of air molecules. That means a upward acceleration, right? And it is already experiencing g due to earth. Since it is falling from great height, what will happen due to this acceleration or due to this resistive force? G will decrease. G is 9.81 meters per second square. And from this value, it will keep on decreasing after some certain point. And that decrease, so G is decreasing. That means these two are totally incorrect. Now we have two options, A and C, where G is increasing. Now, since it is falling from great height, after some point, G will be close to zero. That means the overall acceleration, acceleration net with G minus A. A is the acceleration, upward acceleration due to air molecule, and it will tend to zero. It will tend to zero. This value will tend to zero. So we can see option number A. This graph perfectly shows how G varies and tending to zero. After some point, the acceleration, net acceleration will be almost equal to zero. So this is the one which shows it perfectly. So option number A is the correct answer. Whereas option number C, it is decreasing, but it is not tending to zero. It is tending a constant value, which won't be correct. Why? Because it is falling from great height. If it was falling from lesser height, then it was true. This C was true. But since it is falling from great height, at some point, G will be almost equal to zero. Or acceleration, net acceleration will be almost equal to zero. So this is the correct answer. Thank you.